I'm sure it's all fine there. So moving on, cyclopropane. So cyclopropane, I think you will realize here is C3H6. You realize it's CnH2n. Okay, you think it's alkene, but it's not alkene. It's an alkane because the carbon are saturated. Well, it's a saturated hydrocarbon. Okay, but you can convert it to propene, which is also C3H6, which is also CnH2n. So why are they isomer? Well, both have same molecular formula, but different structural formula. One has no double bond, one has carbon-carbon double bond. Okay, so this is basically what is isomer, or what are isomers, yeah? So next question is asking you on how the rate changes with time. Okay, refer to the graph. I'm going to very quickly draw a tangent. I'm sure you heard of this word called tangent because you do it in maths. I can't do it. Use a ruler. Yeah, okay. I don't have a ruler, so okay. So there's this best of a tangent I can draw. Okay, and then you will have, well, like that. Okay, so I hope you can see that the steepness of the slope is slowly getting less and less steeper until eventually become horizontal. Okay, so here this means no further change in concentration. This is propene. Propene is on the right. Propene is your product. Okay, why does it start at 0, 0? At time equal to 0, no reaction. Okay, so rate is to do with the change in concentration over change in time. Okay, so rate is defined as the change in concentration over change in time. Okay, you can think about it as how the concentration changes with time, therefore it's related to the gradient. Okay, so initially, as shown on the graph above, okay, the tangent, we draw tangents to the curve as time increases, show decreasing gradient, therefore the rate decreases. Okay, so the rate decreases over time. Okay, how the rate decreases over time? Yeah, okay. So initially, decreases over time until eventually there is no further change in concentration of propene. Okay, 0 gradient. Reaction finishes. When your reaction finishes, then your rate will go back to 0. Okay, so yeah, I mean, that's it really. I mean, I show the lines on the graph. I talk about the decreasing gradient. I talk about decreasing gradient as the product is formed until there's no more product being formed. That's why the concentration of propene is no longer changing and the rate will become 0 eventually. Now we want to talk about the change in concentration on the rate of reaction. This is the cyclopropane. This is a reactant. Okay, so when we have more with more concentrated cyclopropane, meaning to say you increase the concentration of cyclopropane, there are more reacting particles per unit volume. Because what do we mean by concentration? Okay, what do you mean by concentration? How many mole of it do we have in 1 dm cube? How many mole per unit volume? So we have more reacting particles per unit volume. Therefore, increase collision frequency. So that means the cyclopropane particles can collide with each other more frequently, okay, in the same volume, because they are more crowded, okay, more crowded together, since you have more of them per unit volume, okay. Therefore rate of reaction will increase. So I've gone on to explain first instead of stating first, but I still remember to state it in the end, okay. Describe and explain the effect of decreasing temperature on the rate of this reaction. So temperature is a measure of kinetic energy. As temperature decreases, okay, the reacting particles, which is basically the cyclohexane cyclopropane molecules, the reacting particles will have lesser kinetic energy. So kinetic energy is to do with your movement energy. So therefore, will move at lower speed or lower velocity, collide less frequently. So we talked about collision frequency before. When you collide less frequency, your rate of reaction decrease, okay? But temperature has two important criteria, one of which is collision frequency. The other one is the more important one. Also, the number of molecules, the number of reacting molecules with enough or with sufficient energy greater than or equal to the activation energy will decrease. So therefore, your proportion or your percentage of effective collision will decrease. So both of these contribute to the overall decrease in rate of reaction. The thing with temperature is that people always think that it's just to do with collision frequency, but it's actually two factors. Temperature also affects this distribution of energy. How much proportion of molecules have enough energy to overcome the activation energy. So you got to complete all of that, yeah. Otherwise, you always have something missing in terms of explaining temperature effect on the rate of reaction. They want you to talk next on the rate of decomposition, hot versus cold. So the key thing is temperature here. So how does temperature affect the movement of particle? So you should appreciate that temperature is a measure of the kinetic energy of the particle. So obviously at a higher temperature, we are talking about the H2O2 particles or the molecules. They can move around faster because they have greater kinetic energy given that your temperature has increased, yeah? So this is all part of kinetic particle theory. That's why they call it kinetic particle theory. But to do with rate of reaction, we need to think about just because they move faster, but how does it affect the rate of reaction? So when they move faster, you also get that there are greater proportion or there are greater number or proportion, so ratio of molecules with there are greater number of molecules with enough energy. So basically with energy greater than or equal to the EA. That means you get more effective collision, or what you would call in O-level more successful collisions. These are part of collision theory, obviously. Therefore, your rate increase. So going back to that idea, kinetic energy, temperature, they are related. Your molecules will move faster at higher temperature. You would get more molecules with enough energy to react. That means with energy greater than or equal to EA. And therefore, as a result, you get more effective or successful collision. As per collision theory, that result in an increase in rate of reaction. think about your white paper, like when you print out this particular paper on a white paper, blank paper, it will look white. That's because they bleach the paper, you know, after they get it from the wood pulp from the tree, they bleach the paper with chlorine in the end. That's why it looks white, yeah. Chlorine reacts with iron to give you iron 3 chloride in a closed container. You increase the pressure of chlorine. What happened to the red? Okay, so you have, well, maybe I should write in there. So the reaction is CO2 gas plus iron solid give you iron 3 chloride. So iron 3 chloride means Fe3 plus Cl minus. So you need 1 Fe3 plus, you need 3 of the Cl minus to give a formula which has no overall charge. All right, this is a solid. It's an ionic compound, right? You don't have water here, so how can you have aqueous? If you don't add in water, how can you have aqueous? All right, 1 iron and 1 iron, that's fine. 3 chlorine, 2 chlorine, you do 3/2. I know some people really don't like fraction. I'm just showing you a primary school calculation. 3/2 times 2 give you 3 chlorine atom. This is molecular chlorine. It exists as Cl2 at room temperature and pressure. I cannot change this to Cl3, yeah? No such thing, all right? Okay, so what do we know? We don't talk about rate of reaction, right? As pressure increase, the only thing that will affect is the gas, because solids, the particles are close together anyway, right? But gaseous particles, they are so far apart, okay? So the reacting gaseous, yeah, very important, affected by pressure, yeah? Gaseous CO2 molecules will get closer together. When they get closer together, they can collide more frequently. They can collide more frequently with the Fe particles, basically the other reactants, okay? Therefore, increasing collision frequency increases. We talk about collision frequency increase, therefore we get more successful collisions. Therefore, rate of reaction will increase. All right, so moving on. So this is the last part of this question. So iron trichloride can act as a catalyst. How a catalyst increase the rate of reaction? Okay, so you know that a catalyst can provide alternative reaction pathway. So that provides an alternative reaction pathway that has new lower activation energy, EN. Okay, this means the proportion, so the proportion or the ratio or the percentage of reacting molecules, or you can use the word particle, reacting particles with enough or sufficient energy that is greater than or equal to the new lower En will increase. If that is true, then the number of effective collisions, okay, the effective collision essentially refer to successful collisions, yeah. Successful collisions will increase, effective collisions will increase. Therefore, rate is increased. Okay, so the reaction gets faster means rate increases. Okay, so rate does not get faster, the reaction gets faster because rate increases. All right. Okay, next bit. Cerium. Cerium is CE there. You need to describe and explain ideas about collision between particles, how the rate changes when concentration decrease. All right, so you don't change any other thing. So as the concentration of sulfuric acid decrease, concentration is the number of mole per dm cube. There's concentration, right? There's the unit, mole per dm cube. How many moles are there in 1 dm cube? How many mole in 1 dm cube? That's the definition, yeah? So we can talk about there are lesser H2SO4 molecules per unit volume. dm cube is a unit volume, yeah? Okay, so therefore, so I already stated the obvious, therefore there are lesser reacting molecules that collide. So if you have lesser reacting molecules that collide, the collision frequency will decrease, or frequency of the collision will decrease, and as a result, rate will be slower. Okay, how the rate changes? So there's one point there. Well, the rate will be slower. Okay, slower, or rate will decrease, something like that. All right, when you use large pieces versus powder, which are, you know, it's talking about surface area really. Okay, so larger pieces, you gotta describe and explain again. Larger pieces of cerium will have smaller surface area, than powdered cerium. Therefore, powdered cerium will have a greater collision frequency. Okay, because changing surface area has to do with frequency, because you have greater area of contact, yeah, greater collision frequency due to greater area of contact with reactive particles, with reacting particles of the H2SO4, because you are reacting cerium with H2SO4, yeah. Okay.